Notes for chapter 10.7. These are going to be a little bit more fun for geometry because it's very much more closely, I think, related to Algebra 1, even though you may or may not have seen this in Algebra 1, but it definitely lead into Algebra 2. A lot more calculations and just work with general numbers, but still, of course, directly related to circles. So we're going to work with the equations of circles. And the standard of equation of a circle, you're going to need to write this down. And what I mean by standard equation of a circle, kind of like the idea that the standard equation of a line is always y equals mx plus b. And we knew that the slope stood for m and the b was a y-intercept, and we knew how to graph those. Circles also have a standard equation, but it looks a little bit more complicated than y equals mx plus b. It is x minus h in parentheses squared plus y minus k in parentheses squared is equal to the r squared, and probably the only one that you know is r for radius. It's equal to the radius squared. X and y, meaning, yep, we're going to put them on a graph. We'll be graphing our equations of our circles. The center of the circle is at the point h and at the point k, or at the coordinates h and k. So this will be the x value of the center of the circle. This will be the y value for the center of the circle. So we know how far over and how far to go up or down. And the radius, of course, is the r. What are we going to do with that circle? We're going to work with the equation of a circle with the radius is 3, whose center is at the origin of the graph. Now we're starting easy. Origin is easier to work with because, of course, the zeros that it represents. And if we know the radius is 3, we'll take our standard equation of a circle and say x minus 0, because that's our h, squared, plus y minus k, which is also 0, squared, equals radius squared. That's how it's going to start out, because, of course, the center is not always going to be at the origin. We clean it up from there. You don't need x minus 0 squared, it's just x squared. You don't need y minus 0 squared, it's just y squared. But you do have to clean up the answer, the result, as 3 squared equals 9. So if anybody who knows anything about a circle, they would know that on a graph, the center is there and the radius of that circle was 3. That's basically what we're looking for. This time it says, write the equation of a circle with this given information. We'll start with this. The radius is 5, and the center is at 0, 0, again at the origin. So do you have to put x minus 0 squared? Not if you're familiar. If it's at the origin, it's at the origin. Equals 5 squared. 5 squared is 25. Try it again, just don't get tricked by the diameter. If the diameter is 14, the radius is only 7. So be careful on the reading, not necessarily just the math. X squared plus y squared equals 49. 7 squared, your center is at 0, 0. Okay, what if your center is not at 0, 0? What if your center is at 2 and negative 5? Write the equation of a circle with the given information. We want that equation to stay in standard form. If we keep it in standard form, then anybody who looks at it that knows anything about circles can tell where the center is and how big it is by the radius. So knowing that radius r is 8, h is the 2 value, and k is the negative 5, we're going to put that in the standard form with x minus h, which is 2 squared, plus y minus k, careful, no, k doesn't stand for careful, y minus negative 5 squared equals radius squared. That is pretty much standard form, but we're going to clean it up. Of course, you'll never write two negatives, so we're going to go parentheses x minus 2 squared plus parentheses y plus 5 squared minus a negative is a positive, and 8 squared is 64. Take a look at this. So now when somebody else sees that, they have to recognize, okay, my h value is 2, so that means I'm going to the right 2, but my k value must be negative because the original formula has a subtraction sign. So if I have a plus sign here, the only way that that would happen is if my k is negative and it went down 5. So somebody who knows anything about standard form of a circle knows that the center is at positive 2 and negative 5. Let's try it again with this one. Radius is 4.2. Just threw in a decimal there for you. Center is at 0, so x minus 0 squared, plus y minus, again it's a negative 9 squared, equals radius 4.2 squared. With the x minus 0, you don't have to leave the 0, or actually you can't leave the 0. We're going to write it as x squared, clean it up, plus y plus 9 squared, again with the positive, equals 17.64, which is what you get if you take 4.2 squared. Again, if somebody looks at this and they know anything about circles, they'd say, oh, the center must be at 0 and it must have gone left 9 with a radius of whatever the square root of 17.64 is, which is 4.2. So this is the final answer that you're looking for when asking for the equation of a circle. That was supposed to be moved. Oh well. And there's your final answer. And then it gets just a little bit more complicated, but this is the fun part. This is where you get to do some algebra and some calculating. The point 3,4 is on a circle with a center at 1,4. Write the standard equation. Wait a second, they didn't give us a radius. But they did give us a point on the graph, which is at x and y. They did give us the center, which is h and k. And if we go back to the original formula, standard equation of a circle, x minus h squared plus y minus k squared equals r squared. If we know what x, h, y, and k are, we can solve for r. We can find radius. Let's try it. Our x is 3 minus our h is 1 squared plus our y is 4 minus our k is 4, interesting, and that's going to equal our r squared. Hopefully we can find r out of this. 3 minus 1 is 2. 2 squared is 4. 4 minus 4 is 0. Oh, so r squared equals 4, which means r itself must equal 2. But we don't actually have to find r. We can leave it as r squared, because that's what we use in our formula anyway. We did all that work to find r, but it still asks us to find the standard equation of the circle. Now there's more points than that on the circle. If our center is at 1, 4, and this is at over 3 up 4, well that's a point, and this is a point, and this is a point, and this is a point. We don't need just one single point. We need all of the points. How do we get that? With a radius. So we go back to x. Any x will work. Minus, but we do need the center. X minus 1 squared. Plus y minus k. K in this case is 4 squared. Equals radius squared, and again our radius squared is 4. So now we're back to equation, well let me do 4. Equation of a circle with standard form. Put the x back in, put the y back in. Try one more. Why don't you try this one on your own? Write it down, pause this equation, or pause this video, and when you come back, see if you have the same equation I do. All right, you're back. You should have labeled x and y, h and k, plugged in x and h and y and k, and did the math. Careful when you're squaring a negative. Of course, it's still positive. Negative 4 squared plus 3 squared is 25, and that's our r squared. No reason to square root that because we need r squared. Then go back to the beginning of your h and k, it's x minus -1, which makes it a plus y minus 3 squared equals 25. All right, so if you can believe that, that's only about half of our notes, because now we get to put it on the graph. Whether it's on a graph and we make an equation, or if we get an equation and we make a graph. Write the standard equation of this circle. First thing we're going to have to do is find its center. Where is the center of the circle? Here's the origin. We went left. 1, 2, 3, 4. So we went left 4. And up 1, 2, 3. If our center of our circle is at -4 and 3, we know that's h and k. We also need the radius. There's lots of places that you can measure the radius. Actually, there's an infinite amount of places. But you don't want to measure the radius like that, because you can't count diagonally on a graph. How big is the radius? Measure anywhere that you can, from center to the edge. 1, 2, 3, or I could go this way, 1, 2, 3, or I could go this way, 1, 2, 3, or that way, 1, 2, 3. Any of those, our radius is 3. Now, we go right back to the original problem with the equation. X minus -4 minus our center, which is plus 4 squared, plus y minus 3 squared equals 3 squared, which is 9. So it's not so bad. Doesn't really take much longer than doing an original problem. This time, here's the equation. Let's graph it. X minus 8, or h, but it's 4 squared plus y plus 2. You got to find the center of the circle. Center of the circle is at h and k. I hope you've been paying attention. K is not 2. K is -2, because it's y minus k. Y minus -2. This one is +4 because it's x minus h. So h is actually 4. What is our radius? The square root of 36 is 6. So we're going to have to plot a center at over 4, 1, 2, 3, 4, and down to, there's the center of our circle, a radius of 6, 1, 2, 3, 4, 5, 6. Or maybe you want to do this way, 1, 2, 3, 4, 5, 6. Or you probably should also count down, 1, 2, 3, 4, 5, 6. And over 1, 2, 3, 4, 5, 6, right to the edge. Good luck. Try to draw a circle going from here to here to here. Yeah, your circle probably looks like mine. Not so good, unless I can cheat it. Oh, you see the problem. My graph is wider than it is tall. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Look at how wide these squares are compared to how tall they are. Makes it a little bit of a goofy circle. But you get the idea. Let's try the next one. This one is x plus 1 squared, y plus 3 squared. If you're getting good at this, you know your center is at -1, -3, and your radius is 4. Left 1, down 3. Radius of 4, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And a circle-ish. And then the rest, you're doing your homework on the rest of the worksheet. Draw the circles the best you can. Your worksheet probably has some crooked squares also, or rectangles as we call those. All right, good luck with this. Have fun drawing circles.